So in this video, we're going to build the inverse cosine function. So first I want to start with the graph. And so what does the graph looks like? Well, it starts at 0, 1, and it works its way down. It comes back up. And that's one cycle that way, and then you can complete and keep going this way. So when you look at this, any horizontal lines that you draw, they're going to cross the graph in infinitely many spots, okay? So we have to pass the horizontal line test and the vertical line test, no problem with the vertical line test, for this to have an inverse. So what do? We restrict the cosine from the top all the way down to the bottom, all right? So from the maximum to the minimum, okay? So I'm going to restrict it. Well, where does that occur? Well, this is going to occur from x equal to 0. Here when we cross, that's pi over 2, and so that means that right here, this is x equal pi. So y equal to the cosine of x restricted to the interval zero to pi, okay? 0 to pi. So x is between 0 and pi inclusive, right? On this interval, we are a 1-to-1 function. Right. So the equation is written, all right? The equation for cosine inverse, this is y equals the cosine inverse of x, which is the same thing as x equals the cosine of y, where x is stuck between -1 and 1, and y is stuck between 0 and pi. Okay? All right. So here y is the angle whose cosine is x. So y is the angle whose cosine is equal to x. Because the range of the cosine function, y equals the cosine of x, is -1 to 1, then the domain of the inverse function is -1 to 1 here, okay? Remember, if I have the domain of some function f, that's equal to the range of that inverse function, okay? With inverse functions, you know, all we do is we swap x and y, okay? So if you think of x as your domain and y as your range, literally the domain becomes the range, and the range becomes the domain for the inverses, okay? So if I'm going to graph this, so say, let's try to graph this. So I'm going to graph cosine. So cosine let me see if I can do a better job of this. Okay. Maybe not the best. Let me see if I can do a little bit better. Maybe that's a little bit better. So 0, 1 here, and then this point here, this is pi comma -1, okay? If I'm going to flip it, all right, across the xy line, okay? So if you think about it, this point right here is actually pi over 2 comma 0. So I'm going to replace, so the inverse, so that is the cosine. So this is y equals the cosine of x, okay? So now what I'm going to do is I'm going to graph the inverse. So this is 1 comma 0. And then I go up here and I have something that looks like this. Okay, so this is negative 1 comma pi. This is 0 comma pi over 2. That, my friends, is y equals the cosine inverse of x. Okay, so it's reflected across this line. Okay, if I drew it correctly, y equals x, so I reflect. Okay, reflect across that line there to get the inverse, because I'm swapping my x with my y value. Okay? All right, so hopefully that will help you out as we start to transition into finding exact values for arc cosine. You know, one thing that we could do, we could just write out a couple of the values. Okay. So, wouldn't hurt to do that. So, table. Okay. Now, what do we know? Okay, so if I have theta and cosine theta, okay, if I'm talking about a unit circle, at 0, at theta 0 degrees, the cosine of theta is equal to 1, okay? Because cosine is your x value. So that point right there is 1 comma 0. So it's cosine theta is 1. So at angle of 0, it's 1. At pi over 6, what do we have? We got square root 3 over 2. At pi over 4, what do we have? We have square root 2 over 2. Pi over 3, we have 1/2. What's happening? It's getting smaller. X value is getting smaller and smaller and smaller until the x value actually becomes 0 for that pi over 2. Okay? And now the only thing that's changing on this side of the unit circle is all these values become the negative of what they were. Okay? So like 2 pi over 3, this is negative 1/2. 3 pi over 4, that's negative square root 2 over 2. And 5 pi over 6, this is negative square root 3 over 2. And then last, at pi, we're to negative 1. Okay? All right, so hopefully that will help us, because now all you have to do to get the inverse is to swap your x and your y, right? Okay, so let's find exact value of, well, let's try cosine inverse of 0. Okay, so what is the angle? Okay, what is the angle that produces a cosine of 0? Okay, so think about this. Set this equal. Remember, the cosine inverse tells us angles, so set this equal to theta. Okay, so theta is stuck between what values? 0 and pi. Okay, so we're only concerned with those top two quadrants. Okay, quad 1 and quad 2. And so the angles between 0 and pi. Now, if I do cosine on both sides, I get cosine cosine inverse 0 equals cosine theta. So 0 equals the cosine of theta. So what does that tell me? Okay, what can I plug in for theta that's going to get me 0? Well, I think an x value of 0 would be pi over 2, right? That's what this is telling me, okay? So theta would be pi over 2. And this is good for us because pi over 2 is between 0 and pi. Right? So if it lies outside of that range, then it's not allowed. Okay? Say we had like the, let's just do one more just to make sure we got it. If I had the cosine inverse of 1 over the square root of 2. Well, 1 over the square root of 2, if I rationalize the denominator, that's square root of 2 over square root of 2 multiplied by 1 over square root of 2. So that's square root of 2 over square root of 4, which is square root 2 over 2. So I hope that looks familiar. Square root 2 over 2, okay, set that equal to theta. Then that means the square root 2 over 2 is equal to the cosine of theta. What theta can I plug in to get square root 2 over 2? Well, if I plug in a pi over 4, then I get square root 2 over 2. Okay? And so this is between 0 and pi, so we're good to go. All right, guys. Good luck on that.